All right, the first video in our rotation series. Here are three isometric transformers, rotator, reflector, translator, and we will start our adventure with rotator. Here is Mr. Rotator, and when he has an 18th century style musket drawn to his head, what does he do? He simply spins out of the way to get out of danger. Then what happens if he's repointed at? Oh, I'll just spin more. Whoop, there. Can't shoot me now. And then what if we can just keep going all day? Now, clockwise versus counterclockwise are two different directions that we may rotate. Remember, just clockwise, think of a clock. The hands go kind of round this way. Counterclockwise is to go the opposite direction. Now, the precise definition of a rotation is a transformation in which a figure is turned about a fixed point. So think of a clock. The fixed point is the center where the hour and minute hands are kind of bound together with a, I don't know, a bolt or some sort of screw to keep them in place. So this is our, what's referred to as the center of rotation. And the amount of rotation is called the angle of rotation. So for example, if we started the pre-image at the 12 hand and our minute hand is our image, then the amount of rotation between 12 and 3 would be 90 degrees. Now, by default, our rotation direction will be counterclockwise, which seems kind of backwards. Why don't we talk about clockwise? Well, let's talk about this thing. In our coordinate planes, we have four different quadrants, 1, 2, 3, and 4. And quadrant 1 is where our x and y coordinates are positive and positive. And to name all the other quadrants, we go counterclockwise, which is the main reason why the default direction in rotations is counterclockwise. Now, what we're going to do is we're going to look at how the x and y coordinates are affected by three different types of rotations: a 90-degree rotation, a 180-degree rotation, and a 270-degree rotation. Okay, and there will be exact specific things that you will notice happens. So first, let's start with a 90-degree rotation, or how many degrees clockwise is that? Let's jump back to here real quick. So 90 degrees clockwise, or 90-degree rotation. 90-degree rotation means we're going to end up somewhere over here in quadrant 2. Now, if I wanted to go clockwise, this would be 90 degrees. And then if I went another 90 degrees, I'd be over in quadrant 3. And then if I went over another 90 degrees, I'd finally be over in quadrant 2. So 90 degrees, 90 degrees, and 90 degrees all together makes a 270-degree clockwise rotation. So 90 degrees counterclockwise is the same thing as 270 degrees clockwise. And you can always figure this out because guess what these two numbers add up to be? 360, because I need to end up at the same spot to make a full circle. One goes one way, and the other goes the opposite direction, but together it makes a full circle. All right, so let's take a look at, with Sketchpad, what's going on here. So 90-degree rotation, here's point A, which is currently located at 3, 2. And if I wanted to rotate it 90 degrees, it's going to end up over here in quadrant 2. So I'm just going to show you some rays. Here is a 90-degree angle. Notice coordinate A is on one of the ray that makes up our 90-degree angle here. So we know that A prime is going to be somewhere along this ray, but where exactly it's going to be at is what we'll get to with our compass and protractor in the third video of this rotation series. So in the meanwhile, we're just going to say we're going to rotate this thing over, and there's where it ends up, at the point -2, 3. Now one thing we notice is these coordinates match up with those coordinates kinda, right? There's a 3 and a 2 and there's a 3 and a 2 here, but they've flip-flopped places. The old x is now the new y, and the old y is now the opposite of the new x, sorry. The new x is now the opposite of the old y. Okay? Now, is that always true? Well, let's move our points around. So spinning, 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 big money, big money, big money, no whammy, stop. Let's see. New x is the opposite of our old y, and our new y is exactly our old x. So one thing switches, the other doesn't. So let's spin one more time. Around and around she goes. Where she stopped, nobody knows. Stop! All right, so our new x-coordinate for our image is the opposite of our old y-coordinate. Our new y-coordinate is our old x-coordinate. No switching involved there. So now let's write our written explanation of what's going on here. So there's two parts we got to look at, the x and the y. So the new x-coordinate, we'll just say the new x, we won't even say bother with the word coordinate. The new x is the opposite of the old y. And we said the new y is the old x. There was no opposite, there was no flip-flopping there. So if we were to write out the transformational rule here, here's our original pre-image x comma y. Then we said our new x is the opposite of the old y. So here's our new x, and the new x-coordinate is the opposite of the old y, so it'd be negative y. And then our new y-coordinate right here is just the old x-coordinate. So we have that flip-flopping going on here. The x and y flip-flop, but really it's only the y's that switch sign, I should say. The x's just switch location, but not sign. So here's our 90 degree or 270 degrees clockwise rotation about, notice this is about the origin. This is where, let me jump back to my picture here, the angle, not the angle of rotation, the center of rotation is at the origin here. That's where things were rotating around. There's where our 90 degree angle is really located at. All right, so now let's look at a 180 degree rotation. Well, remember I said if you wanted to figure out how many degrees that was going around the other way, that those two numbers would have to add up to be 360. So 180 counterclockwise plus 180 clockwise would make our full 360. So let's see what that looks like. So 180 degree rotation means if we start in quadrant 1, we're going to end up somewhere in quadrant 3. Likewise, if we went clockwise, we'd go around this way and end up in quadrant 3. So here's our 180 degree angle, which is just a straight line. So A prime is going to be somewhere down on this ray, and it's going to be exactly right here at -3, -2. So again, we noticed, hey, 3 and 2, 3 and 2. The 3 is still in the same spot. The 2 is still in the same spot, but we notice that the coordinates have changed signs in both the x and the y. Let's see if that's still true once we spin this thing around. Stop. So let's see, -2, 1. So the x has stayed in the same, but it switched signs. It was negative, now it's positive. The y-coordinate was positive, now it's negative. But notice they're still the same number, 1 and 1. Just one's positive and one's negative. Let's spin it one more time. Stop. And we get the same scenario. Okay, we got negative, negative. Now it's positive and positive. So let's write up our rule. So our written explanation is the new x is the opposite of the old x. It was the same number except one was positive and one was negative. Now I don't want to say the new x is the negative of the old, because then you might think, well, the new one always has to be negative. But what if the old was negative? Well, then a negative negative makes a positive. So I just use the term opposite instead of negative there. And then the new y is the opposite of the old y. So x and y stayed in the same spot, except they just switched signs, essentially. Okay, so we said x and y, they stay, except they now switch signs, the x and the y both. So there would be our transformational rule. X is still x, y is still y, but they switch signs. Now let's talk about a 270 degree counterclockwise rotation, which would have to be a 90 degrees clockwise rotation. So let's take a look at that. So again, here's our 3, 2. Here's our 270 degree rotation. Remember, we're going 90, there's 180, now 270, or this would be our 90 degrees clockwise rotation here. And here's where A prime's located. So we notice again that, like with the 90, they got flip-flopped, but is it the same rule necessarily? Well, let's test it. All right, so we notice that our new x-coordinate is the same as our old y-coordinate. Our new y-coordinate is the same as our old x-coordinate, except the sign got switched around. So let's spin this sucker around. Let's see where we end up. All right, so we said our new x-coordinate is the same as our old y-coordinate, and our new y-coordinate is the opposite of our old x-coordinate. So let's write that rule down. So the new x is the old y, and the new y is the opposite of the old x. All right, so if our new x is the old y, then that would just be that. That's our new x is now our old y. And our new y is the opposite of the old x. Well, is that the same thing as the 90 clockwise, or 90 counterclockwise and 270 clockwise? Let's jump back here. So they flip-flopped, but the new x-coordinate was the one that got switched. Now they get flip-flopped, but the y-coordinate is the thing that gets switched. So they're very similar, except the sign gets switched either on the x or the y-coordinate. So very, very similar there. All right, so now we're going to use those 3 rules, and we're going to figure out some image coordinates from our pre-image coordinates. So 90 degrees clockwise about the origin. Well, 90 degrees clockwise, we just said was, hey, that's like this one, really 270 counterclockwise. So we just want to take, and this will be easy for me, that I can just copy and paste. So this is the rule we want to follow. Okay, so the thing that stayed the same was the old y-coordinate is just now the new x-coordinate. Okay, so here's the old y-coordinates. These are all the old y. And now they get to come over here, and they're all my new x-coordinates. Okay? So this will be 4, 1, and 6. And then my old x-coordinates now become my new negative x-coordinates for my y. So really, I want to take all of these, switch the signs, and put them in over here. So if that was positive 2, this is now negative 2. Positive 4 becomes negative 4, and positive 1 becomes negative 6. And that way, I don't have to do any graphing, but I know where those coordinates are going to end up, thanks to this rule. All right, example 2, we're going to do 180. So I'm going to go back. Here's 180. And here's the rule. All we did for 180 rotations was the x and y stayed the same. They stayed in the same spot, except they switched signs with each other. Okay? So 8, 7 is still going to be 8, 7, except it's going to be negative 8, negative 7. 3, 4 now becomes negative 3, negative 4. And 4, 3 now becomes negative 4, negative 3. Easy enough. Once you use the right rule, then just applying the rule to get the image coordinates hopefully won't be that bad. Number 3, 270 clockwise. Well, 270 clockwise was the same thing as 90 degrees counterclockwise. So we want to use this rule now. So let's put that into place. So our old x-coordinate is now our new y-coordinate. Okay, so all of our old x's, which would be the 4, 7, and the 5, they get to come over and they are now our new y-coordinates. So that's 4, that's 7, that's 5. And then all of our old y-coordinates become our new x-coordinates, but we got to switch the signs on them. So 9, 2, and 5 now become negative 9, negative 2, negative 5. And we're done. If we were to graph all the pre-image and the image coordinates, we would find that there really is a 270-degree clockwise rotation between all of those pre-image and image coordinates. Now, I'm going to leave the last one to you, okay? And I'm going to check this as part of your homework grade that you really did this. Now, I love this picture. This is what you definitely look like whenever you see what this problem looks like. But again, we didn't really do anything mathematical with the numbers, right? We didn't add or subtract or multiply or divide or, anything of that nature. So it really shouldn't matter what these coordinates are. But you just need to know that the rotation you're going to do is 270 degrees. And since I didn't say clockwise, you are to know that this is counterclockwise. So use that rule and apply it to these coordinates to tell me where the coordinates of the image will be located. And that is all for the first video of rotations.